Now we talk a little about the barometer and the atmospheric pressure. The atmospheric pressure, its measurement is so important to us. It plays an important role in our daily life. So इसीलिए even whether it is Met Office or even in general talk, we discuss the atmospheric pressure, the pressure at sea level, above sea level, and so on. और आपको पता ही होगा जनरल नॉलेज से कि हम कहते हैं कि जिस वक्त हाई प्रेशर है तो इट्स ऑल सनी, धूप निकली हुई होती है, और लो प्रेशर हो तो इट इनवाइट्स रेन. तो अगर बारिशें होनी हो लो क्लाउड में, लो प्रेशर में क्लाउड्स इकट्ठे हो जाते हैं और देन देयर इज ए रेनफॉल. तो इसकी मेजरमेंट्स, इसकी इम्पोर्टेंट, इट हैज़ ए वैल्यू, the planes are flying, and so many other uses there. It has application. So it's important to us that we should know the change, the atmospheric change that is taking place as far as pressure is concerned. Atmospheric pressure is measured by a device that is called barometer. Thus, the atmospheric pressure is often referred to as barometric pressure. तो बाज़ औक़ात हम एटमॉस्फेरिक प्रेशर को बैरोमेट्रिक प्रेशर भी कहते हैं, क्योंकि एटमॉस्फेरिक प्रेशर बैरोमीटर से, डिवाइस कॉल्ड बैरोमीटर, जिस तरह से ब्लड प्रेशर वगैरह जो ट्यूब की फॉर्म में होते हैं वो मैनोमीटर से मेजर किए जाते हैं, तो इसी तरह यहाँ पर वी अप्लाई बैरोमीटर, एंड बैरोमेट्रिक प्रेशर इज ऑल्सो द सेम थिंग एज एटमॉस्फेरिक प्रेशर. बैरोमीटर क्या है? एक सिंपल ट्यूब है, as you can see in the picture. The pressure at point B is equal to the atmospheric pressure, and the pressure at C can be taken to be zero since there is no mercury vapor above the point C, and the pressure is very low relative to atmospheric pressure and can be neglected to an excellent approximation. अगर हम इस पिक्चर को दोबारा देखें तो सी सरफेस पे एटमॉस्फेरिक प्रेशर शो हो रहा है, उससे ऊपर एयर है. सो दैट इज व्हाट इज बीइंग रेफर टू. और प्रेशर बी है क्योंकि इफ वी डिप द ट्यूब, द इन्वर्टेड ट्यूब, इनटू ए सर्टेन कंटेनर containing a liquid, in this case a mercury, और आमतौर से mercury is a good standard for measuring pressure. So writing a force balance in the vertical direction, it will give us atmospheric pressure to be rho gh. ये हम पहले डिस्कस कर चुके हैं. और वर्टिकल डायरेक्शन में unless there is a significant change in the density of the liquid under consideration, इसकी वैल्यू हमेशा कैलकुलेट की जाती है rho gh से. And this formula, although it's very simple, but it's very important. It's used in hydraulics, irrigation, fluids, etc., etc. Not many applications. Rho is the density of mercury in this very case. G is the gravitational forces as always, and H is the height of the mercury column above the above the surface. Note that the length and the cross-sectional area of the tube have no effect on the height of the fluid column of a barometer. तो ये फार्मूले से भी यह जाहिर है, P is equal to rho GH. तो इसमें हाइट तो शो हो रही है, वर्टिकल हाइट तो वेरी करेगी इफ इट वेरीज, लेकिन एज फार एज द डायमीटर और द क्रॉस सेक्शनल एरिया ऑफ द ट्यूब इज कंसर्न, ना वो उसमें शामिल है और ना उसको कंसिडर किया जा रहा है. सो इट मीन्स दैट इट इज not important, not being considered, and it does not play any role in calculating the pressure in the vertical direction. A frequently used pressure unit is a standard atmosphere, which is defined as the pressure produced by a column of mercury that is 760 millimeter in height at 0 degrees centigrade. This is, you can see how important it is. The temperature 0 degrees centigrade, because that is the standard temperature that the scientists have agreed to consider. And we know that with temperature the density changes. It changes not much for the liquids but for the gases. और क्योंकि अगर हम एटमॉस्फेरिक प्रेशर कंसिडर कर रहे हैं तो at very large heights, vertical heights, the density may significantly change, and therefore these values and standardization. So the standard atmospheric pressure is considered to be 760 millimeter in height at 0 degrees centigrade, and mercury की density is taken to be 13.595 kilogram per meter cube under standard gravitational acceleration, and where the value of G is equal to 9.807 meter per second square.